Hello, welcome to today's tutorials, which covers concepts in section 7.1, properties of the normal distribution. Now, in chapter 6, we looked at the discrete distribution, and in chapter 7, we are looking at the continuous distribution with special attention on the normal distribution, which is an example of a continuous distribution. What that means is the random variables that we see under this distribution will be variables that we can measure. Okay, for example, the height, the IQ level, the mileage, miles per gallon. Okay, those are continuous variables, but then they become normal random variables when the kind of shape that they produce is bell-shaped. Okay, a symmetric shape and bell-shaped. So for the first problem, it says determine whether the graph can represent a normal curve. If it cannot, explain why. So pretty much the problems we see here is to be able to determine whether the curve we see is a normal curve or a bell-shaped curve. So for the first one, 1a, it is not a normal curve because obviously it is not bell-shaped. Okay, so that is the first thing that is violated here. It is not bell-shaped for 1a. Then 1b is a normal curve because it is bell-shaped and the tails of the curve, right, as the on both sides approach the horizontal axis and never cross the axis. Okay, so as x increases without bound, the graph approaches but never reaches the horizontal axis. Also, as x decreases without bound, the graph approaches but never reaches the horizontal axis, never crosses the horizontal axis. Alright. Then for 1c, what we see is that it looks bell-shaped, but then at the tails, the curve crosses the horizontal axis. The curve crosses the horizontal axis. And also for D, 1D, it looks bell-shaped or symmetric, but then as the tail approaches, the horizontal axis, then it begins to rise. Okay, on both sides. Therefore, this is not a normal curve. 1D is not a normal curve because the tails are just not approaching the horizontal axis and continuing in that direction, but then they approach and begin to rise at some point. So that is not a normal curve. Now 1E is a normal curve because it is bell-shaped, it is symmetric, and as the tails of the curve approach the normal axis, the horizontal axis, they do not cross. They approach it but never cross the horizontal axis. And 1F, this is not a normal curve because obviously it has two peaks. Okay, it may look symmetric. This graph looks symmetric, but it is not bell-shaped. It doesn't have just one peak, so it is not a normal curve. Okay. Now we go to number 2, which also looks at the properties of a normal distribution again, where we assess certain things about it. So the question goes, one graph in the figure on the following page represents a normal distribution with mean mu equals 10 and standard deviation sigma equals 3. The other graph represents a normal distribution with mean mu equals 10 and standard deviation sigma equals 2. Determine which graph is which and explain how you know. So for any normal distribution, we have what we call the parameters. Okay, so for any normal distribution, we need to have information on the mean and then the standard deviation. So for this very two curves, we see that they share almost like the same central point, like the peak. Okay, the two curves they peak at the value 10. Okay, and for any standard, any normal distribution, the peak happens at the mean, the median, and the mode. Okay, so it means that for A and B, their means are going to be 10. But then where the difference comes in is when you look at A is tighter together and then B is more spread out. Okay, and the spread of a distribution is what we call the standard deviation. So the higher standard deviation will be for the more spread out curve, and in that case that is 3. So the standard deviation for A is 2, the standard deviation for B is 3. Alright. Then for problem 3, it says one graph in the figure on the following page represents a normal distribution with mean mu equals 8 and standard deviation sigma equals 2. The other graph represents a normal distribution with mean mu equals 14 and standard deviation sigma equals 2. Determine which graph is which and explain how you know. So with the two graphs, we kind of see that they have the same shape, but then their peaks happen at different values. Okay, so for A's peak happens at when x equals 8, and B's peak happens at where x equals 14. And remember, the peak of a normal distribution occurs where on the horizontal axis you have the mean. So for A, the mean for A is 8, and then the mean for B is 14. But looking at it critically, you realize that the spread for A and the spread for B are the same. So they have their spread, which is the standard deviation sigma, being equal to 2 for both of them. So A has a mean of 8 and standard deviation of 2. B has a mean of 14, standard deviation of 2. Okay. Then we move on to how to interpret the area under the standard normal, under the area under the normal curve. Okay, the area under the normal curve. Now, the area under the normal curve is the same as the probability, okay, for a particular region under the curve. Okay, and the sum of the area under the normal curve equals 1, which is the same as the sum of the probabilities, okay, of any distribution. The sum of the probabilities of any distribution equals 1. The sum of all the probabilities of any distribution equals 1. So with that in mind, let's look at this problem. So 4, Elena conducts an experiment in which she fills up the gas tank on her Toyota Camry 40 times and records the miles per gallon for each fill up. A histogram of the miles per gallon indicates that a normal distribution with mean of 24.6 miles per gallon and a standard deviation 3.2 miles per gallon could be used to model the gas mileage for her car. A, the figure represents the normal curve with mu equals 24.6 miles per gallon and sigma equals 3.2 miles per gallon. The area under the curve to the right of x equals 26 is 0.3309. Provide an interpretation of this area. So there are two ways that we can interpret the area under a normal distribution or a normal curve. So the first one is when you look at it in terms of proportion. Okay. So we say that the proportion of times that Elena gets more than 26 miles per gallon is 0.3309 because the shaded region is beyond 26, okay, beyond when x is 26, and therefore the proportion of time that Elena gets more than 26 miles per gallon is 0.3309, which is the area. Now, when we look at it in terms of probability, it says that the probability that a randomly selected fill-up yields at least 26 miles per gallon is 0.3309. At least 26 miles per gallon is 0.3309. Because when in the range, in the interval, you realize that the least value is going to be 26. Okay. So, a similar question. B, it says the figure represents the normal curve with mu equals 24.6 miles per gallon and sigma equals 3.2 miles per gallon. The area under the curve between x equals 18 and x equals 21 is 0.1107. Provide two interpretations of this area. So the first one, we realize that the shaded region is between 18 and 21, and the area over there is 0.1107. So anything that we talk about will be between 18 and 21 miles per gallon. So in terms of proportion, the proportion of time that Elena gets between 18 and 21 mpg is 0.1107. Then in terms of the probability, we say the probability that a randomly selected fill-up yields between 18 and 21 mpg is 0.1107. Alright, so these questions give us, it introduces us to what the properties of the normal distribution are. Okay, so in our next tutorial, we are going to see questions under section 7.2, which has to do with the applications of the normal distribution. Thank you.